Good day, students. Today in JSS 2 Basic Technology, we are studying energy conversion, specifically how mechanical energy is converted into electrical energy. This is one of the most important processes in modern civilization because virtually all the electrical energy that powers our homes, schools, and industries begins as some other form of energy that is converted to electrical energy. Energy is the ability to do work. Energy exists in many forms: mechanical energy, thermal or heat energy, chemical energy, electrical energy, light energy, sound energy, and nuclear energy. One of the fundamental principles of science is the law of conservation of energy, which states that energy cannot be created or destroyed, it can only be converted from one form to another. Energy conversions happen all around us. When you eat food, chemical energy is converted to mechanical energy in your muscles and heat in your body. When you burn fuel in a car engine, chemical energy converts to mechanical energy and heat. In this lesson, we focus on converting mechanical energy to electrical energy. The device that converts mechanical energy to electrical energy is called a generator or dynamo. Generators work on the principle of electromagnetic induction, discovered by the English scientist Michael Faraday in 1831. Faraday discovered that when a conductor moves through a magnetic field, or when a magnetic field moves around a conductor, an electric current is produced in the conductor. This is called electromagnetic induction. In a generator, coils of conducting wire are wound on a rotating part called the rotor or armature. The rotor is placed inside a strong magnetic field, usually provided by permanent magnets or electromagnets. When an external mechanical force rotates the armature, turning it round and round, the wire coils continuously cut through the magnetic field lines. This induces a voltage in the coils, which drives an electric current through the external circuit. In most large generators, it is actually the magnets that rotate, called the rotor, while the wire coils are stationary, called the stator. The mechanical energy that turns the rotor can come from many different sources. Steam turbine generators are the most common type used in large power stations. Water is heated to produce steam, which spins a turbine connected to the generator. The heat to boil the water may come from burning coal, natural gas, or oil in thermal power stations, from nuclear reactions in nuclear power stations, or from the heat of the earth itself in geothermal power stations. Nigeria's Egbin Power Station in Lagos and Sapele Power Station use steam turbines driven by natural gas. Hydroelectric generators use the energy of falling or flowing water. Water stored in a dam flows through tunnels and spins water turbines connected to generators. The falling water's gravitational potential energy converts to mechanical kinetic energy in the spinning turbine, which then converts to electrical energy. Nigeria's Kainji Dam on the River Niger is the largest hydroelectric plant in Nigeria, generating hundreds of megawatts of electricity. Wind turbines convert the kinetic energy of wind into mechanical rotation, which drives a generator. Wind turbines are increasingly used around the world as a clean, renewable energy source. Northern Nigeria, with its open Sahel terrain, has potential for wind energy generation. Solar panels, also called photovoltaic cells, convert light energy directly into electrical energy without any mechanical moving parts. Silicon semiconductor cells produce a small voltage when light falls on them. Multiple cells are connected to form solar panels. Due to Nigeria's abundant sunshine, solar energy is increasingly important. Many homes, schools, and businesses in Nigeria now use solar panels for electricity, especially in areas not connected to the national grid. Internal combustion engine generators, commonly called gensets or diesel generators, burn fuel in a piston engine to produce mechanical rotation, which drives a generator. These are extremely common in Nigeria because of the unreliable national electricity supply. Millions of Nigerians depend on fuel-powered generators for their homes and businesses. Alternating current (AC) versus direct current (DC). Most large generators produce AC, alternating current, where the direction of current flow reverses 50 times per second in Nigeria's system. AC is used because it can be transmitted over long distances efficiently at very high voltages, then stepped down using transformers at the destination. Batteries and solar cells produce DC, direct current, which flows in one direction only. The complete chain of energy conversion in a typical Nigerian power station is chemical energy in natural gas, heat energy from burning, mechanical energy in spinning turbine, electrical energy in generator, electrical energy transmitted through the grid, light, heat, and mechanical energy in our homes and offices. Understanding energy conversion is fundamental to solving Nigeria's electricity challenges. Engineers and technicians who understand how electricity is generated, transmitted, and used are critical contributors to Nigeria's development. As you progress in your technology education, you will study these topics in even greater depth.